Okay, in this example, we're talking about intervals of increase, intervals of decrease, and intervals of constant uh, functions. So let's talk about this for a second. What does it mean for a function to increase? Well, if a function is increasing, all right, suppose that you're increasing on the number line, okay, in the x direction. If it's increasing, the next y value will be bigger than the previous y value. So let's look at this. If we were to pick this point here and this point here, notice x is getting bigger, right? But the y value here is bigger than this y value. So this right here is the interval of increase, okay? So from here off to infinity. So that's the interval of increase. So I'm going to denote it with an I and with an arrow up, okay? So the interval of increase is going from 3 to infinity. All right, now the interval of decrease, well, what does that mean? That means that the previous y value was greater than the subsequent y value. So take something like this, for example. Notice that the x's continue to get bigger, but what happens? The y value gets smaller. So this interval right here, and this is coming in from this direction, so this is out at negative infinity, and it stops at 3. The area of decrease is from negative infinity all the way up to negative 3. So we have this region right here where it's decreasing. Now, the area where it is constant, where it does not change, there's no variation, it kind of flat lines, is this area right here. Notice that the previous y value is the same as the subsequent y value. So this area right here, in between negative 3 and 3, and we'll denote it like this area between negative 3 and 3 is where it's actually constant. So this is the area of decrease, and this is the area where it is actually constant. So just a quick look at what it means for a function to be increasing, what it means for a function to be decreasing, and what it means for a function to be constant.